about solving systems of equations, and we've done it by graphing and we've done it by elimination. So there's one more method that we're going to talk about. So if you look in your packet, we are on the page that says topic 4 right here, and we're going to do example 1 together, and we are going to do example 8 together. Alright, so we are on following along with our packet. So we can just read the steps that are in our packet. So solve one equation for one variable. That may already be done for you, or you may need to do that. Plug that equation into another equation. Solve that for whichever variable you have left, and then plug your answer back in to solve for the other variable. So it kind of seems like a mess of words, but once you do an example, I think we'll be okay. So this example is number 1 in our packet, and we have y equals x plus 3, and we have x plus 3y equals 33. So if we have this, and we want to solve this system, so again, we're looking for what coordinate point makes both of these true, where they would intersect if we were going to graph them. So if we wanted to solve this, like right away, it's not easy to graph this because I would need to get y alone here. And it's not easy to do elimination because we have y equals x plus 3, whereas this one is x plus 3y equals 33. So this one, the x and the y are on different sides of the equal sign. This one, they're on the same. In order to do elimination easily, we need them to be on the same side of the equation. Okay, so step 1 says to solve each equation for one variable. That has already been done for us. So that's already been done for us because we already have y alone. Okay, but if we didn't, we'd have to get one of the variables alone. It doesn't matter which one. And now it says plug that equation into the other equation. So I'm going to say that this equation, give me 1 second. Okay, so I'm going to say that this equation right here is pink. So what's going to happen is I'm going to take this pink guy right here, and I'm going to plug him in for y. So we have x plus 3. And now instead of y, we know that y is equal to x plus 3. So we can just plug that in for y. Okay, and all of that is equal to 33. So all we did so far is we said, okay, we know that y equals x plus 3, so now we can just plug it in. So now what we're going to do, and why this is beneficial, is now we only have one variable. Okay, so before we had these 2 variables, that's not that helpful. Here, now we just have 1. So now we're just going to solve for x. So we have x plus 3, x plus 9, because I used the distributive property here, and then that still equals 33. I'm going to combine like terms here. I get 4x plus 9 equals 33. I need to get x alone. I'm going to subtract 9 on both sides. So we get 4x is equal to 24. Therefore, that x must be equal to 6. Okay, so far we solved one equation for a variable. That was done for us. Step 2, we're plugging that equation into the other one, and we solve for the variable that we have left. So we've done all that. Now we just need step 4. Step 4 says plug your answer back to solve for the first variable. Okay, so all we're doing here is we found our x coordinate. We also need to find our y coordinate. So we can take this x equals to 6. We can plug it into either one of these equations. I'm going to plug it into the top one because it's already solved for y. So we have y equals x plus 3. All I'm doing is I'm taking that 6 and I'm plugging it in for x. So we have y equals 6 plus 3. So we have y equals 9. So my coordinate point is 6, 9. So what that means is this is a coordinate point that makes both of these true statements, and if I were to graph these two things, this is going to be where they intersect. So it's important that we write our answer as a coordinate point. Don't just say x is 6, y is 9. Okay? So we're also going to do, I believe it was 8 in your packet, so we're looking for this one right here. So with this, we could solve for elimination. We could multiply this top by -2 because this has this 2x, and so if I multiply the top by -2, then my x's are going to cancel out. Or we could solve it for elimination, or substitution, but it's really up to you. So if we look at, we're going to practice substitution because that's what we're working at. So if we look at this right here, x or y, neither of them are alone. So I need to get either x alone or I need to get y alone. And so when I look at this, the obvious choice to me is to solve for this x because it's already close to being alone. All I need to do is subtract this 14y. So I'm going to take this one here and I'm going to rewrite it as x is equal to -84 minus 14y. So all we did is we subtracted 14y here. Okay, now I have one variable, or one equation, where I have it solved for a variable. So now I'm going to take this x equals -84 minus 14y, and I'm going to take this part right here, and I'm going to plug it in for x. So what we have is 2, and now we're rewriting x as this right here, so we can get an equation just in terms of y. So then I'm going to write -84 minus 14y. So all I did is I just substituted in my new value for x because we know that x is equal to that, plus 28y is equal to -7. So far we completed step 1, we completed step 2, and now we're going to just solve this for y. That's going to be step 3. So 2 times -84 minus 14y is going to give us -168. I'm just going to make sure that I distribute, minus 28y, and now I have this plus 28y is equal to -7. So now I'm just going to combine like terms. So I get -168 minus 28y plus 28y. Those are going to cancel each other out. So I no longer have any y's, equals -7. This is not a true statement. So we have done this time and time and time again. When my variables cancel out, if we are left with a false statement, we know that this is going to be no solution. So what this means is that there's no coordinate point that makes both of these true. So graphically, those must be parallel lines. So if we look, I plug them in and I graph them. So here, you can see it. So the purple one is x plus 14y equals -84, so down here. And then 2x plus 28y equals -7 is this orange line. So these are parallel lines, meaning they're never going to intersect, which is why it made sense that that is no solution. There's never going to be a place where they intersect. Okay, so this would be no solution. Okay, so your homework is just to make sure that you have filled in these problems together. Okay, you don't need to do any more problems. You obviously can if you would like to. Okay, see you later.